The identities in this section deal with, first of all, multiple angle identities. All right. So let's just look at a few variations here. Now, suppose I have 2 sine x. Okay. What is that really? That is 2 of the sine x. So if I had 2 apples, that's, one apple and another apple. This is really sine x plus another sine x. Okay? Now, so if I had, for example, 2 sine of 50, that would be sine of 50 plus another sine of 50. Okay? Now, suppose I had sine of 2x. You see the difference now? This is not sine x plus sine x. This is 1 sine, okay? And I have x plus x. What does that mean? Suppose sine x, suppose I have sine of 50. Okay? Now, sine of 2x is not sine of 50, it's sine of what? 100. Okay? That's the difference. So if I have 2 sine x, the angle stays the same. It's sine of 50, sine of 50. But here the angle changes. So if I was taking the sine of 50, which is in the first quadrant, now I'm taking the sine of 100, which is in the second quadrant. All right, so things are just completely different. For those, we have completely different identities. So here's the first one. If I have sine of 2 theta, it's just 2 sine theta cosine theta. And it's been my experience that students just end up memorizing that because it's just, I don't know, it just seems easy. Tangent of 2 theta is this. Okay? Now, for cosine of 2 theta, you have 3 choices. And you can use either identity depending on which one you have to work with. Okay? Now, one more thing. If you already know sine of 2 theta and you already know cosine of 2 theta, then you don't have to use this for tangent. You can also say tangent is just the sine of 2 theta over the cosine of 2 theta. All right? Just make sure that all of these angles are the same. You can't mix a theta with a 2 theta. All right? Yeah. Nothing in section 5. You don't have to memorize anything in section 5. So whatever is on that sheet that I gave you right now, you don't have to memorize any of it in section 5. Okay, so let's do the first one. We have sine of theta is 3 over 4. I have to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta. In each of the formulas, right, I need a sine and a cosine, and I need a tangent, right? So what I need to do first is use the identities from section 1 to find cosine theta and tangent theta. Okay? I'm not even going to start with the identities from this chapter yet. Okay, so if you have sine of theta, how do you find cosine of theta? Well, sine squared theta plus cosine squared theta equals 1. So here we have 3 over 4 squared plus cosine squared theta equals 1. 9 over 16 plus cosine squared theta equals 1. Cosine squared theta is 1 minus 9 over 16. That means cosine squared theta is 7 over 16. That means cosine of theta is 7 over 4, root 7 over 4. I'm going to take the positive one. Okay? Yeah, for these, let's do that. Yeah. Because the negative will fix itself right now. Now, I'm actually going to use the shortcut, so I'm going to forego the tangent here. So look at what we're going to do. Sine of 2 theta is a formula right above in that box. It's 2 sine theta cosine theta. Now, you have 2. Sine theta is 3 over 4. Cosine theta is root 7 over 4. This is 2 times 3 is 6. Root 7 over 16. And then we have to simplify the 6 and the 16, right? How can we simplify? By 2, you get 3 root 7 over 8. So that's your sine of 2 theta. Okay? Now, I need to find cosine of 2 theta. Well, what's the formula for cosine? I have either one of these. So which one do you guys want to use? Let's use the bottom one. Cosine 2 theta equals 1 minus 2 sine square theta. Why am I using that one? No reason at all. Just pick that one, okay? So 1 minus 2 times sine square theta is 9 over 16, right? Now I cancel the 2 with the 16 and I get an 8 here. So this is 1 minus 9 over 8. So cosine of 2 theta is negative 1 over 8. Because 1 minus 9 over 8 is negative. Negative. Well, 9 over 8 is bigger than 1, right?
So why did we find cosine?
Well, because we used it here. You see? Okay. Now, for tangent of 2 theta, I'm not going to use this formula in the box because it gets sort of complicated. All I'm going to do is sine of 2 theta over cosine of 2 theta. So this is sine of 2 theta over cosine of 2 theta. So let's just simplify that. 3 root 7 over 8 times negative 8 over 1, negative 3 root 7. So those are my 3 answers. If you're only given tangent and you're told, yes. Okay? All right. Next. This. Okay. Now, this is an equation that we have to solve. And it says cosine 2 theta, and here I have a cosine theta. Remember how in the previous sections we couldn't have an equation that mixed a sine and a cosine, or like 2 different trig functions? Similarly, you cannot mix a double angle with a single angle. All your angles have to be either all 2 theta, or all 3 theta, or all just simple theta. Okay? So first, we have to convert all 2 thetas to theta. The way we do that is this. Cosine 2 theta has a formula. Okay? Now you see where the choice really matters. Cosine 2 theta has 3 options. Okay? I'm going to use the one with only cosines, because then the rest of my equation only has cosines. All right? So I'm going to use the second one. Okay? So choose second option, for cosine. Okay, because the rest only has cosines. So it's going to be 2 cosine squared theta minus 1. This is going to be 2 cosine squared theta minus 1. Okay? The rest of it remains unchanged. So I'm just going to copy it over. Minus cosine theta equals 2. All right, let me just bring everything to the same side and rearrange this. 2 cosine squared theta minus cosine theta minus 3 is equal to 0. So now, you guys remember how to do this? This is like old stuff now. You factor, okay? And I have 2 cosine theta, cosine theta. I'm going to have a 3 and a 1, right? So I'll have the 1 here and the 3 here. Good old-fashioned guess and check. Because minus 1, and then, wait, this minus 1?
Yeah. Oh, they just combine it with.
This is part of the formula. Cosine 2 theta is, yeah, yeah. So now where does the positive go in our, but they do, Brooke, they do. Because now I have 2 cosine theta minus 3 cosine theta. It's just beautiful. This. Okay, this is an identity. So look at the box at the very top. Okay, the right column, the third one. 2 is 2 cosine squared theta minus 1. Right? So this cosine 2 theta is 2 cosine squared theta minus 1. Let me just highlight it. This is this. Okay? And then the rest of the equation just copies over. I just substituted. So now, 2 cosine theta equals 3. Cosine theta equals 3 over 2. Here, cosine theta is equal to minus 1. Let's do that one first. Cosine is the x-coordinate. Where is the x-coordinate minus 1? At pi. So here, x is equal to pi. Now here, where is cosine theta equal to 3.5, which is 1 over 1.5? Where is cosine equal to 1.5? What's the highest cosine values can go? 1. And what's the lowest they can go? Negative 1. So it can never go above 1. So this is no solution. Okay? Yeah, sine theta or cosine theta can never be greater than 1. Right. Tangent can be. Remember the graph of the tangent?
Oh, yeah.
Okay. Now, I'm not going to do this derivation, but basically, if you take one of the identities here, all right, well, actually, this one, okay? If you take one of the identities here, like suppose if you take this one, you can solve that one for cosine squared theta, right? You could just rearrange the formula. If you do that, then you get these. So these aren't really anything new. They're just the ones before rearranged, all right? But we're going to work with them. So here is sine to the 4th theta. And what we want to do is we want to write it in terms of cosines of multiple angles with no power greater than 1. Okay? So we want to write it in terms of cosine 2 theta and so on. You can have multiple angles like 2 theta, 3 theta, but no exponents. All right? And okay, I have to say I'm like a little bit partial to this stuff. I love them. I know everything in math is like my child and I love everything equally, but there are just some things that, they take precedence, and this is one of them. So sine to the 4 theta, all right? Now, if you had x to the 4, can you write that as x squared squared? We can do that, right? So if you have sine to the 4, can we write that as sine squared squared, like this? Sine squared theta squared. We can do that. Why do we do that? Because I don't have any formulas for sine to the 4 theta, but I do have formulas for sine squared theta. So whatever the exponent here is, if I just write it as squared to the power of something else, then I can use this one, all right? So rewrite this in terms of sine squared theta to another power. Now, what is sine squared theta though? Sine squared theta is 1 minus cosine 2 theta over 2. And I want to do that squared. Huh? Over 2 though.
Right, but like
No.
the other identity from way back.
No. So now what I'm going to do is FOIL this one. So I get 1 minus, okay, in the numerator, this is going to be a fraction. 1 minus 2 cosine 2 theta plus cosine squared 2 theta over 4. Okay? Now, this is fine because it's got no exponent, but I've got an exponent there. Okay? Well, now I'm going to do another substitution there. Okay? Here is the other substitution. Everything else stays the same. 1 minus 2 cosine 2 theta over 4. Now, what's the substitution going to be? What's cosine squared of an angle? What's cosine squared of an angle? It's 1 plus cosine 2 of the angle over 2. So bear with me here. Look. It's 1 plus cosine 2 of the angle. What's the angle here? 2 theta. I know. Okay, so this says, if you have cosine squared theta, you do 1 plus cosine 2 times whatever your angle is here. It doesn't matter. So this says theta, right? If instead of theta, you had 2 theta, so basically whatever this angle is, you double it here. If this wasn't theta, if this was cosine squared book, then here it would be cosine 2 book. You know what I mean? If it was cosine squared table, then here would be cosine of 2 times table. You just double the angle. Over 2. So now this is this. I never said it was going to be clean. So what happens here? 1 minus 2 cosine 2 theta plus 1 plus cosine 4 theta over 2. All over 4. Now, can I do a common denominator for the top here? Sure I can. Okay? So look, here I have over 4. Okay? This has a denominator of 2, right? So I'm just going to multiply everything by 2 over 2 to make a common denominator. So what do I get now? I have 2 minus 4 cosine theta Yet to make a common denominator, plus 1 plus cosine 4 theta all over 2. So now I have a fraction divided by 4. So this is 2 minus 4 cosine theta plus 1 plus cosine 4 theta over 2 times 1 over 4. Now because something divided by 4 is that times 1 over 4. Here we have an 8 on the bottom. And now let's simplify some things here. 2 plus 1 is 3 minus 4 cosine theta plus cosine 4 theta. Where? But if you're dividing by 4, then it's times 1 over 4. Right? So if you have like 3 divided by 4, that's like 3 times 1 over 4. Think about it. You know this. You're just having a moment. You're having a moment. All right. All right, I'm going to move to to example 5, and then come back to this equation. Okay, so let's go to example 5. Now, these are half-angle identities. This helps you, okay, evaluate trig functions like sine, cosine of the special angles divided in 2, okay? So we use for special angles divided by 2. For example, what's a special angle? 45 divided by 2. How much is that? 22.5. 30 divided by 2. How much is that? 15. So if you want to find the sine of 15, we have no idea how to find the sine of 15. But because 15 is half special, it's, right? It's a special angle divided by 2, then I can work with it. 22.5, on its own, it's really nothing. But if you think, okay, 22.5 is the 45 divided by 2, then you can work with it, okay? So it's like you have some angles that have, you know, like some claim to fame with the other special angles. Again, you don't have to memorize any of these. So here we want to do sine of 22.5, okay? Now, 22.5 is 45 over 2, right? This is what you use as your theta. Okay? So 22.5 is theta over 2. 45 is theta. So now, sine of 22.5 is equal to, we're going to use this one, plus or minus the square root of 1 minus cosine of theta. What's theta? 45 over 2. Then I'll tell you exactly why I love these. Now, plus or minus, are we going to take the plus or the minus? Well, is our angle in the first or the second quadrant? First quadrant. So we take the plus, okay? So since theta is in quadrant 1, use the plus. So now, this is the square root of 1 minus, what's cosine of 45? Nice. So now, lots of fractions here, okay? when you have a whole number added or subtracted to a fraction, you do a loop. This times this is 2, minus that one, root 2, over 2. That's the shortcut. What's another way? Multiply this by 2 over 2, subtract. All roads lead to Rome, okay? All roads lead to adding fractions properly. Okay, so what do I have here? In the square root, I have 2 minus root 2 over 2 divided by 2 is the same as times 1 over 2. So this is the square root of 2 minus root 2 over 4. Okay? So this is the top, right, is the square root of 2 minus root 2. And what's the bottom? Just 2. And that's the final answer. And the reason why I love these half angle identities is because you can get a square root inside a square root, and there is nothing more beautiful than that. Is there? I don't think so. I mean, like, there is nothing more beautiful than that. Okay? Huh? You know, it's close. It's close.
Venice sunset.
No, overrated. Okay, so I'm skipping the equations because I want to get you guys used to substituting identities. So here is another set of identities. Okay, so in calculus, sometimes it's necessary to work with functions that look like this. Okay, so it's cosine of some angle and then sine of some other angle completely different. Luckily, we have identities for those, okay? Like those Greeks, I'm telling you, they just gave us everything. Yeah, so look, you use these when you have sine of something else, cosine of something else, or sine, cosine, and they're different angles, okay? So use when multiplying trig functions with different angles. Like this one, cosine 6x, cosine 3x. Of these four, 1, 2, 3, 4, which one of those does it match with? The second one. Okay? So use number 2. All right, so here, this is my alpha, this is my beta. So this is going to be half, in brackets, cosine, alpha minus beta, 6x minus 3x, plus cosine, alpha plus beta. This is half cosine 3x plus cosine 9x. And you can either leave it that way, or you can say, distribute the half, and it's half cosine 3x plus half cosine 9x. But really, there isn't much to do. Like, it's not really that stimulating. It's just like plug and chug. Okay? That's it for that one. I mean, it's not very stimulating mentally. Okay? And then sometimes you have the sum, like you're adding. Okay, so what if you're adding functions with different angles? Then you use these. So look, you have cosine something plus cosine something else. So of 1, 2, 3, 4, which one are we going to use for this one? Number what? Number 3. And it's just going to be cosine of the first, 2 cosine of the first angle plus the second angle over 2 times cosine the first angle minus the second angle over 2. This is going to be 2 cosine, and I actually have these done. 225 cosine of 30. We can do these. What's 225 like? What's the reference angle? It's 180 plus what? 45. So cosine of 225 is like cosine of 45. So what would that be? What's cosine of 45? Root 2 over 2, except 225 is in this quadrant where cosine is negative. So it's negative. And what's cosine of 30? Everybody knows now what cosine of 30 is. Root 3 over 2. Yeah, there's a 50-50 chance. These 2's will go away, so it's negative root 6 over 2. All right, so let's do a couple of the equations. Why can't I use the word equation? I can't say equation. All right. So look at example number 4.
This isn't your favorite? Is this one your favorite?
I love them, and there's like so many to contend for my favorite.
No, when you were talking about
I know.
better than your children.
And then
Is
now
it
that
this?
has been recorded.
Was it
That's
this?
better than mine. I said no such thing. All right. So here we have an issue. We have an issue because we have an angle theta and an angle 2 theta, and they just don't mix with each other. But luckily we have an identity for cosine squared theta. What was the identity for cosine squared theta?
1 plus cosine 2 theta over 2.
Oh, look at that. You guys memorized it already. Minus cosine 2 theta equals 1 over 2. Okay? You know what I'm going to do here is get rid of that 2 because it's annoying. So I'm going to multiply everything by the common denominator, which is a 2. Because we're pre-calculus students now, and we learned that in algebra, and we know how to do that. So we get 1 plus cosine 2 theta minus 2 cosine 2 theta equals 1. What do we get here? The 1's go away, right? And what do we have left when the 1's go away?
So is that negative cosine theta, or does it not work that way?
Oh, wait a minute. Okay, I'm sorry. I was looking at solutions, but of a different problem, and I'm like, why don't they match? Well, because it's a different problem. Okay, so these go away. So now I have negative cosine 2 theta is equal to what? So cosine 2 theta is equal to 0. Now, where is theta equal, what angle gives a cosine of 0?
Pi over 2.
Pi over 2. So now, what's my angle here though? So I'm solving for this now. So I say 2 theta is pi over 2, and where else? Yeah. Okay, so where is cosine 0? Pi over 2. So this angle, 2 theta, is 0 at pi over 2. Okay? But we have to solve for theta. So how do we solve for theta? Divide by 2, divide by 2, divide by 2, divide by 2. So then theta is equal to pi over 4. Theta is equal to 3 pi over 4. But we have to solve these over negative to positive infinity, so we add 2n pi to n pi. No, doesn't matter at all. Okay, so here there are 1 and 2 equations, right? I'm gonna continue the screencast for the 2 equations, and I'll put it online like in 20 minutes, so you can watch those. And this homework is due Monday. Oh, wait a minute. When is this due?
We have Wednesday's our next class.
I'll tell you. Hold on.
We got next class Wednesday.
This is due Wednesday.
And then our test is Thursday?
Yes.
Oh my gosh.
So,